Next. Perfect. My name is Joop Snijders, and I would like to share some information about a debugging project we started in the Netherlands, and at the end invite you to join. I work for a company called Atrato IP Networks. I do network stuff there, but it's of less relevance to this presentation. Let's dive right into it. The NLNOG RING started in the Dutch network operator group. The Netherlands is a small country between Belgium, Germany, and France. It's probably 4 times the size of this ballroom. And it's not as formal as NLNOG is. We have a mailing list on IRC channel, we hang out and drink beer, but there are not meetings like this. Nevertheless, we did start the RING. The RING, in a metaphysical sense, is an awesome network debugging platform. And I emphasize platform because you can do lots and lots of cool stuff with the RING. The foundation for the RING is trust. I trust you with access to my resources as you trust me with access to your resources. I'll talk a little bit about how the RING came to be, what the motivation was to start this project, about the current size and scope of the RING, and I'll give some practical examples of common network debugging issues you might face in your daily life and how the RING simplifies them. In December 2010, a friend of mine had some IP-related issues. A random collection of source IP addresses towards a random collection of destination IP addresses over a certain layer 2 internet exchange just didn't work. And he asked his friends, can you take a look from your network? I've visualized the networks on the bottom side of the slide. Imagine I am the orange guy. And he would phone people, email them, talk to them on IRC and ask for ping sweeps or trace routes. And he would get data back, often without a timestamp. And all in all, it took him quite a few days to gather enough data to build a case to what could possibly be the issue he was facing. So we conclude with a stolen image from Lord of the Rings that one does not simply debug networks. It can take a lot of time to gather enough data. So wouldn't it be much, much easier if the guy that had this problem could just log into different networks surrounding the exchange and run all these tests himself and not bother with asking people because he has direct access? This is how the RING started. 10 organizations gave each other shell access to machines, and from that moment on, those organizations could debug layer 2 load balancing issues like this much, much easier. We started with 10 organizations, but it has grown quite a lot now. We're in 33 countries, and there are over 150 boxes around the world. As you can see, Europe is heavily represented. America could use a little bit more. But this has grown to a very big debugging project. And if you join, you get access to all these machines around the world to do any test you desire. If we look at participants, we see participants from all kinds of different markets. There are IP transit providers that have joined, content providers, access networks, NRANs, even an RAR joined. And there are also competing companies in this image. And that's okay within the RING, because in the case of unidirectional packet loss, both parties are losing. This is where the RING helps you to provide better service to your customers on both sides. If we look at a simple example of what you get when you join the RING. In this example, I log into the node that my organization has provided to the RING, and I can issue a command that is called ring ping. The ring ping command logs into every node and executes an ICMP ping and gives back the results and aggregates this nicely for you. I've done the test both on IPv4 and IPv6, and it's noteworthy to see that on average there is a slight difference between the v4 and v6 latency. It's outside of the scope of this presentation to dig in why that is, but as an operator this might be of interest to you and might motivate you to get better peering or transit. If we look at the v6 ping I executed, there are two hosts that cannot reach this particular website. In the v4 version, you see that Akai 01 cannot reach it, but that's because it's a v6 only node, so v4 won't work. If we look at Resopol 01, I can just log into that node now, run a traceroute, or in this example, an MTR, and I see that the MTR strands somewhere in TNet. So maybe their prefix is not being propagated properly, or they're being blackholed for unknown reasons. But with these two commands, I can very quickly zoom in and see where an issue might be and email the relevant parties. Other CLI uses, with the access you have to all these boxes, is, for instance, you can run dig, the DNS utility, to check whether your domain name resolves from all these autonomous systems. And if you do geo-IP-based DNS stuff, this will give you insight whether the DNS-based stuff you do in the geographical context is working as you expect it to work. You can also run a traceroute from all these servers. And if I type ring all MTR some flags a target, I'll end up with a screen that has 150 traceroutes towards that single target. And if that target has two upstreams and you see half of the ring incapable of reaching the target and the other half works, you know within seconds what's going wrong. And because you have shell access, you can script your own tests, you can do whatever you want. So be creative. You can do MTU testing, firewall testing. There's a lot of things you can do. We also have a web interface. The web interface is developed by the same guys that developed Scamper and other cool tools. Our web interface is still in beta phase. This, for me, is just an excuse that if the web interface sucks or we provide shitty service, we can point at the beta label. The web interface, the concept behind it is that on every ring node, a daemon runs. And this daemon does tests towards all other ring nodes. It tests jitter, MTU, it records trace routes, it records packet loss, and it tries to gather as much metrics as possible and store these in a central location. And that central location is our web interface through which you can dig. So let's dive into that. This is a matrix with, on the left side, all US ring nodes, and on the top side, again, the same US ring nodes, and then you have a mesh with the any-to-any IPv4 packet loss. And you see, I know it's awfully small, so please download the slides afterwards if you want to zoom in. But you see a lot of green. Everything that's yellow, that's deviating from what was recorded in the previous hour. So you get a very real-time-like view on how a certain country is doing. If we look at the v6 packet loss, the results are slightly different. There's a little bit more instability and less is colored green. We also have a tab for MTU. If we look at IPv4 MTU, almost everything is green, except for the purple row in the middle. Again, that's our IPv6 only node, so it cannot do path MTU discovery in that IPv4 address family. If we look at IPv6 within the US ring node region, it's a little bit more disappointing. A lot of nodes, for some reason, cannot do path MTU discovery properly. This could be due to firewalls or other issues. You see a lot of the cells are colored yellow. This is because they have 20 bytes less compared to the 1500 MTU standard. So this means they're tunneling or using transitional technologies that eat up MTU. For you as a network operator, overviews like this are very interesting to see how are you doing compared to the rest? Is this normal behavior in this country, or is everybody in that state far away through connecting through tunnels? The web interface also allows you to really zoom in on network issues you might have. For instance, if I click on certain targets, I can get historical graphs with, on the left side, all US nodes, and their, in this case, jitter towards one specific target graphed over time. You see a small red dot there, and we can zoom in on that red dot and see what was going on at that time. If we zoom in, we can have graphs like this, similar to what smoke ping does, except there is no smoke in this graph. And it maps out jitter, packet loss, and latency. And indeed, at 4 a.m. this morning, there seemed to be some kind of problem between SoftLayer 05 and Netflix 01. We can also view trace routes from that particular point in time. And we see that at 4 a.m., the trace route was slightly different than at 45 minutes later. So maybe there was some backbone issue or a cable got cut, I don't know. But the ring provides you with a possibility that if you get a trouble ticket, that customers complained 3 days ago about a degraded service, you can actually go back in time and try and troubleshoot what was going on at that particular time. Not only you can confirm was the customer right, because you have the ring as your neutral point of view, and you can also see paths taken at that particular time. And this web interface works for both v4 and v6. We believe in feature parity between the address families. The ring is governed by a rough consensus process. So we have a mailing list, and people can voice their opinions, and based on that input, we decide our direction. Aside from that, there are 4 ring administrators, and they just do the technical hands-on work. They install new nodes, they provision new user keys, and troubleshoot if needed. They perform the software upgrades, do the security maintenance, so all of the management of a ring node lies with these 4 people. We have a very active community. That's why we have, for instance, AMP. There's a lot of time and energy is being spent on writing cool tools that make common tasks easier to execute. And remember, the ring is a community effort. It is built by us, network operators, and for us as network operators. It's here to make inter-domain troubleshooting easier. Joining is very simple. It's free. I use the word gratis because it also works in Dutch. All you need is a single machine. This can be a virtual machine as long as it has a 64-bit CPU. You are required to give it at least one IPv4 and one IPv6 address. And you need to have those addresses in the default free zone with your autonomous system. So this project is for network operators. You can fill in an application on ring.nlnog.net. There's a huge ugly button. You can't miss it. And ring nodes, you should consider them as a regular co-location customer or a regular customer behind a DSL line. So in terms of security, just treat it as any normal customer and you'll be fine. This concludes my short presentation on the ring. I'm curious, are there any questions?
Scott Librand, Limelight Networks. What's the security model? How do you prevent me from ping-f, guy I don't like?
I believe that you can run ping-f much more efficient if you go to the Russian business network.
So your model is don't scale too big?
Sorry?
So your model is don't scale too big?
Well, as I mentioned in my, one of my first slides, it's built on trust. We've been running now for 2 years. I personally believe in name and shame if anybody ever abuses the ring, and that will not help you.
So it's user account based and you have to sign up, and so it is authenticated at least and
yes,
trackable?
Yes,
okay.
Only ring participants can access ring nodes. And we do accounting. But so far, in 2 years' time, there has not been a single case of abuse. So that gives me hope that we can continue in this direction for the future. Are there any other questions?
I have one. Do you have any idea how much it's used? How much do the participants actually use the servers around in the world?
We do have some statistics. I don't know them from the top of my head, but I'd say it's used a few hundred times per month.
Yeah.
It's hard to measure because, for instance, with Ring Ping, you do an SSH login to every node. So if you execute that single command, you have 150 SSH logins. So those numbers add up quickly. But the Ring is very actively used by a lot of participants. And one of the most commonly cited uses of the Ring is to decide, is the customer wrong or am I wrong? So if the customer emails you, it's down, help, P1, I want to speak to your manager, and you execute Ring Ping or Ring HTTP, and you see that the whole Ring agrees that the service is up and running, you can just mail back to the customer, look, 150 nodes are not going to be wrong on this one. It's probably a local fault at your site somewhere. Have a great day. So that's one particular use that is, I think, used hundreds of times per month.
I can confirm that.
Thank you.
Any other questions? Okay. Thank you, Joop.
Thank you for your time, and I sincerely hope you join the Ring.